if we're asked to find the extrema on this particular function with this closed interval, of course, our first step will be to find our derivative. G dash of x is equal to multiply and subtract, multiply and subtract. And now we're going to set this equal to 0. That's what we do. We set the derivative equal to 0 to look for those maxes and mins. Negative 2x equals negative 3 when I subtract 3 from both sides. So x is equal to negative 3 over negative 2, or 1.5. That's my critical value. So I want to find g of 1.5. And when I put those values in there, I realize, oh, sugar, that's out of the domain. Oh, Lordy. So I have no critical value. So if I go left endpoint, critical value, right endpoint, notice I'm only allowed from negative 2 to 1. And I found that my extrema, where my derivative equals 0, happens at 1.5. That's out of the domain. So my left endpoint is negative 2. When I find the function value at negative 2, in other words, negative 2 squared, take the opposite, plus 3 times negative 2 minus 5, I get negative 15. So I'm expecting to be able to do that from algebra. There was no critical value in this particular domain, and my right endpoint was at 1. F of, or g of 1 is negative 1 squared plus 3 times 1 minus 5. And when you plug that 1 in, you get 3. So here's what our little chart looks like when we do this. And you can see that this is our absolute max. Why do I know it? It has the biggest y value. This is our absolute min. It has the lowest y value. So what does this look like? It's going from negative 2, negative 15, all the way up to 1. I'm sorry, when I put in 1 there, I get negative 3 actually. To 1, negative 3. It looks something like that. I can tell it's not going to have any turtle humps or valleys because in this particular domain, I had no critical values. So it's going to look something like this, a very kind of boring graph from negative 2, negative 15 to 1, negative 3. Our endpoints for this graph give us our absolute min and absolute max. Sorry, there's a better view of that.